Hello students. In previous videos we have studied about how Maxwell predict electromagnetic waves, what is the fact behind it, and what is the source for these electromagnetic waves, how they are generated, as well as we studied Hurd's experiment that shows experimental evidence for the existence of electromagnetic wave. So हमने अभी तक मैक्सवेल का प्रिडिक्शन देख लिया, हर्ट्स ने उसको एक्सपेरिमेंटली एविडेंट किया दैट दीज वेव्स एग्जिस्ट, and we have studied about the source of electromagnetic wave. Now we are moving to the properties of electromagnetic waves. So major properties of these electromagnetic waves are, first of all, these waves are produced by accelerated charges. If we have charge but it is stationary or moving with uniform velocity, it is not capable of producing electromagnetic wave. So these electromagnetic waves are produced by accelerated charges. Next thing is that these are transverse waves. These waves are transverse waves and they do not require any material medium for their propagation. They do not require any material medium for their propagation. इन्हें किसी भी मीडियम की नीड नहीं होती है. They can travel in space, in vacuum, in free space, everywhere. In electromagnetic wave, both electric field vector and magnetic field vectors are present. That's why we call them as electromagnetic. And the direction of oscillations of these field vectors are perpendicular to each other, as well as it is mutually perpendicular to the direction of propagation. So the fields they have is E vector and B vector, and direction of oscillation of E vector and B vector is perpendicular to each other, as well as आपस में भी perpendicular होंगे और direction of propagation के साथ भी perpendicular होंगे, as well as these both are perpendicular to direction of propagation. Also, one more thing is there, these oscillations that are happening, means these oscillations of E vector and B vector fields, these are in same phase. So ये जो oscillations होंगे, these oscillations are in same phase. Same phase say we mean that both achieve their maxima and minima at the same instant. उनका कर्व एक साथ एक फॉलो होगा, मैक्सिमा मिनिमा एक साथ अचीव होगा दोनों के ऑसिलेशंस का. दिस इज द फोर्थ प्रॉपर्टी. नेक्स्ट थिंग इज दैट दीज इलेक्ट्रोमैग्नेटिक वेव्स travel in free space, and whenever they travel in free space their speed is same, and that is equal to the speed of light, means 3 into 10 to the power 8 meter per second. So these electromagnetic wave, I am writing them as EM waves, travel in free space with speed v is equal to, given as 1 upon under root mu naught epsilon naught, and its value is 3 into 10 to the power 8 meter per second. This is the electromagnetic waves when travel in free space. Now if it is travel in a medium, if this wave travel in a medium, in that case, now this value is c, the speed of light. So in a medium, this speed v is given as 1 upon under root mu epsilon, right, where mu and epsilon can be given as under root mu r mu naught and same epsilon r epsilon naught. So this value will be under root mu naught epsilon naught and under root mu r epsilon r. So we can write it as the speed is equal to this quantity c upon under root mu r epsilon r, or c upon n, where n is the refractive index of that material medium जिसमें वो वेव ट्रैवल कर रहा है, उस वेव का रिफ्रैक्टिव इंडेक्स होगा n, and it is given as under root mu r epsilon r. These are the permittivity and permeability of that medium. Relative, because r is showing here in the suffix that these are the relative values. So moving to the next property. Next property is that the amplitude ratio of the electric and magnetic field. Now amplitude are the peak values attained by these fields. So amplitude ratio means E naught upon B naught. The amplitude ratio of these electric and magnetic field is equal to C, or we can write it as 1 upon under root mu naught epsilon naught, right? So this ratio is C. Next thing is that the electromagnetic waves carry energy. Since these are energy waves, so they carry energy whenever they travel through the space, and these energy is equally shared by electric and magnetic fields both, right? जो भी total energy होगा electromagnetic wave का, that is equally shared by its electric and magnetic component, and their average energy density means the average energy density of an electromagnetic wave. So if we take it as small u, average energy density u for whole electromagnetic wave is equal to ue plus ub, right? ue plus ub. These are the densities for electric field and magnetic field, and we can substitute their values, then we get the answer half epsilon naught e naught square plus half b naught square upon mu naught, or we can take half common, then it will be half epsilon naught E naught square plus B naught square upon mu naught. This is the average energy density of an electromagnetic wave. Next thing is the linear momentum of this wave. So linear momentum for electromagnetic wave, for this EM wave, the linear momentum P is given as U upon C, where U is the total energy, this U is the total energy transferred by the wave to a surface in time t. So this is the energy. Capital U represents energy, while small u represent energy density. So linear momentum is u upon c, where u is the total energy transferred by the wave and c is the speed of light, or the speed of electromagnetic wave in free space. Next point is the intensity of an electromagnetic wave. So intensity of electromagnetic wave is given as energy per unit area per unit time, and it is equal to u upon a delta t, and if we solve it we get u into c, that is energy density into speed of light, and by substituting the values we get this intensity is equal to half epsilon naught E naught square, that is the value of u into c, and this is epsilon naught square upon 2 is the RMS value का square, so ये हो जाएगा epsilon naught, and E naught square upon 2 is E RMS square. E naught square upon 2 is the E RMS square, because E RMS is equal to E naught upon under root 2 into c. Now this was in the terms of electric component. We can also define it in terms of magnetic component, then it will be half B naught square upon mu naught into c, and on solving this we get B RMS square upon mu naught into c. this is the value of intensity for electromagnetic wave. Now next thing that we can find is the pressure exerted by an EM wave. Since it is a pressure, so it is represented by capital P. Linear momentum small p and pressure capital P, this is the difference, and it is given as pressure is equal to intensity upon C. Since this is the pressure of the radiation, so sometimes we also call it as radiation pressure and denote it as PR. So this PR is also known as radiation pressure because electromagnetic waves are exerting this pressure. So this is radiation pressure and its value is I upon C. Next thing is that the point that we are going to discuss is these electromagnetic waves are not deflected or remains unaffected by electric and magnetic fields. So if these electromagnetic waves are traveling in some region where electric and magnetic fields are present, then these can penetrate that region, that field. They are not deflected by those electric and magnetic fields present in that region. Okay, तो ये जो electric magnetic waves होंगी इनका बिल्कुल भी डिफ्लेक्शन नहीं होगा बिकॉज ऑफ दोज इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स. नेक्स्ट पॉइंट इज दैट कि ये जो इलेक्ट्रोमैग्नेटिक वेव्स हैं, दीज वेव्स ओबे सुपरपोजिशन प्रिंसिपल, राइट. ये सारे वेव्स सुपरपोजिशन प्रिंसिपल को फॉलो करते हैं एंड बाय दैट आई मीन they can show the phenomena like interference or various phenomena which works on the basis of superposition, right. So इनका जो effect होगा when a number of waves are traveling in a region, so individually वो जैसा effect करेंगे उस region को, net जब हम निकालेंगे then they follow the principle of superposition for that, right. And the next and the last thing is that कि जो इलेक्ट्रिक फील्ड है इलेक्ट्रोमैग्नेटिक वेव का, दैट इज मेजरली रिस्पॉन्सिबल फॉर द ऑप्टिकल इफेक्ट्स बिकॉज द वैल्यू फॉर ई नॉट इज मच ग्रेटर देन बी नॉट. सिंस वी नो दैट the ratio of the amplitudes or the amplitude ratio is equal to C, and C is a very large quantity, 3 into 10 to the power 8 meter per second, right. This shows that the value for E naught is greater than B naught, and since this is the case, so because of that the optical effects are shown by electric field of electromagnetic wave. So electric field is majorly responsible for the optical effects that are shown by electromagnetic wave, for example light. So these are all the properties of electromagnetic wave that we have to remember, that we have to study. ये properties हैं, important properties हैं electromagnetic wave के, जिनके basis पे हम बहुत सारे phenomena को study करते हैं. So that's all for this video. For further videos, stay tuned and keep studying. Thank you.